to start doing redox, which is probably new to most of you. We're moving on. We're going to go to chapter 20. The reason we're going into chapter 20 is the last time we did this class, the other kids recommended that we do the stuff that they knew no one had done before first, before doing stuff that everybody was pretty comfortable with. So before we go and do things like Vesper or like, you know, stuff that we've already done.
Are we going to be required to do that stuff in these chapters?
Probably, no. It says determine the, so for this one here, we have to talk about redox. Before we learned how to give things their oxidation states, but we didn't really do anything with it. So just to refresh your memory, let's determine the oxidation state for each thing in the following reaction. Don't everyone go at first.
Zero.
Why is it 0?
Zero.
So something by itself in its normal elemental form is 0. How about these things here, the H and the Cl?
Plus 1 and minus 1 respectively.
Plus 1 and then minus 1. Very good, because when it's an ionic compound, essentially it's just those charges. All right, how about my zinc in this case? Plus 2 because it's ionic. How about my chlorine?
Minus 1.
Still minus 1. And then my hydrogen? 0 by itself. So what I'm going to recommend, and it's borderline require, is that when you're doing these, you need to write down what is changing. So for example, I'm going to write down that my zinc is going from 0 and it's turning into plus 2. What else is changing? Well, my hydrogen. My hydrogen is going from plus 1 and it's changing into 0. Now I want to know what's being oxidized and what's being reduced. Remember, losing electrons is oxidation. So that means that it gets more positive. Gaining electrons, that's reduction, and it becomes more negative. So in this case, what is happening to zinc?
It's oxidized.
Zinc is oxidized, and that means that my hydrogen has to be reduced, because these things come in pairs. They don't just do it on their own.
In a chemical equation, can only one thing be oxidized and only one thing be reduced?
No. But you always have to have an oxidation portion and a reduction portion.
Does it also have to be the same 1-to-1 ratio, or could it be different?
Nope, that's what he just said. So remember that oxidation and reduction have to occur together. You can't have one without the other. And some new terms we have to talk about is the oxidant and the reductant. So the oxidant is also referred to as the oxidizing agent. And your oxidizing agent is the substance that is reduced and thereby causes the oxidation of something else. Your oxidant is the thing that acquires electrons. So if that's what the oxidizing agent or the oxidant is, what do you think the reducing agent or the reductant is? Well, obviously. So we'd say that's the substance.
Oxidizing, thereby causes the reduction.
Yeah, substance that is oxidized. And thereby causes the reduction of the other substance. So if our oxidant is acquiring electrons, what do you think this one's doing?
Losing them.
Yeah, it gives up electrons. Looks like give soup. It says gives up electrons. So in our last one, we said that zinc went from 0 to plus 2, and you said that hydrogen went from plus 1 to 0. And you said that our zinc was oxidized and that our hydrogen was reduced. which one is my oxidant?
Hydrogen.
And which one is my reductant? Obviously, it's got to be zinc. This is one of those things that kind of gives people like a hard time just because it's kind of counterintuitive. You know that hydrogen is being reduced, but it's also the oxidizing agent. It's what's allowing the other thing to be oxidizing up those electrons. So let's determine what the oxidizing agent and the reducing agent are in these two equations. So for the first one, what are you going to have to do to determine it?
First, you get the oxidation state.
You have to get your oxidation states. Very good. So again, it's just good practice. So for cadmium, what's it going to be?
0.
How about your
Plus 2.
+4.
Oh, plus 1.
plus 4?
Wait, but I thought, oh, never mind. O2 is not diatomic in this.
No. Minus 2. All right, my hydrogen
Plus 1.
and your oxygen, minus 2. So my cadmium in this case,
Plus 2.
your oxygen, still minus 2, still plus 1. Your nickel, plus 2. So in this case, what changed? Well, I knew that cadmium went from 0 to plus 2, and my nickel went from plus 4 to plus 2. So what's happening to the cadmium?
It's oxidized.
It's being oxidized. So what is it going
The
to?
reductant.
So it's my reducing agent. Which must mean that, yes, my nickel is getting smaller, so it's being reduced, so that's my oxidizing agent. Everybody okay with that? Do you want to do the other one more time? All right, so what do we have to do? We have to determine our oxidation states. What's the charge on my hydrogens, or my state?
Plus 1.
Plus 1, my oxygen, minus 2, my aluminum.
0.
All right, my oxygen here is still minus 2. What's my
Plus 16.
manganese? Plus 7, thank you. Plus 16, are you cray-cray, yo?
Yeah.
If you look here, this would be minus 8. This is x equal to negative 1. Solve for x. Plus 7.
I know.
Okay. What's the charge on your aluminum? It is plus 3. This is still minus 2. This is still plus 1. It's a complex. They're a metal complex. You should have been able to get that it was still plus 3 because you have 4 hydroxides with each hydroxide having a charge of what? Negative 1. So you have an extra hydroxide, which would mean that your aluminum is still plus 3. How about your oxygen over here?
Minus 2.
Minus 2. How about my manganese?
Plus 4.
Plus 4. So that means what changed?
Manganese and aluminum.
Okay, aluminum and my manganese. So my aluminum went from 0 to plus 3, and my manganese went from plus 7 to plus 4. So which one is my reductant and which one is my oxidant?
Aluminium.
It's my reductant because that is what's being oxidized, and that must make this my oxidant. Yay! Pretty easy, right?
Yeah.
Fantastic. Now we're going to balance them. So balancing redox equations, we're only going to talk about them in an acidic environment. Please pay attention. It says in an acidic environment. When it's in an acidic environment, what ion do you have floating around in solution if something's acidic? That lets you know that we're going to be using hydrogen ions because it's acidic. So when balancing redox, you have to pay attention to the law of conservation of mass and matter, which means that we have to balance the number of atoms we have on both sides of our arrow. And the electrons transferred must also be equal. So if you're losing 3 electrons in your oxidation reaction, you better be gaining 3, or I'm sorry, if you're gaining 3 in losing 3 in oxidation, you better be gaining 3 in reduction because you need to make sure that those are equal. So even though both oxidation and reduction happen simultaneously, the way in which you solve these is that you look at them each in half reactions and then we recombine them. So you're going to have to be able to first determine what's being oxidized and what's being reduced. So we're going to look at half reactions. So the steps to balancing a redox reaction, and again, this is just in an acidic environment. The first thing you're going to do is you're going to write the half reaction for oxidation. You're going to write the half reaction for reduction. Then we have to balance our reactions, which is the whole point of us doing this. To balance the reactions, you're going to follow steps, and they have to be followed in order. First thing you're going to do is you're going to balance all elements other than H and O. After you do that, you're going to balance your hydrogens by adding protons, so by adding H plus as needed. Then we have to balance our oxygens. Oops, I lied to you. That's step C. Oh my gosh. That's C. Sorry, I lied to you. Hydrogens last. Sorry, you balance your oxygens first.
So that should be.
This is B. Balance oxygen by adding water. I was wondering why we had hydrogens already and we didn't have any added. So we add our water to balance oxygens, then we balance our hydrogens, and then finally, you balance the charges by adding electrons. Once you've balanced the charges by the electrons, then what you need to do is you're going to repeat for the other half reaction. Whether it was you started with oxidation or you started with reduction, doesn't matter. Then you need to multiply half reactions by an integer to get electrons gained to equal electrons lost. And then finally, you add them up like you would in math class, and then you cancel what can be canceled. There are a lot of steps to doing redox, and yes, you have to follow these each time. I guess the last thing would be like to double check and make sure everything's balanced.
That's actually an important one.
Yeah, it is. It's the discount double check your work.
There are no shortcuts.
There are no shortcuts, but by golly,
Always a shortcut.
yeah,
You
it's
have to
usually...
follow the math. There are no
They
shortcuts.
always find a shortcut through a bush.
So let's go through and practice them.
Hang on.
There are a lot of steps. We're going to do one together. Well, we might have time to do two together, but we're going to go through and do it, and we're going to follow each step, and you have to follow the steps every time you do it. It's the only way to guarantee it. What? No, not tomorrow, but your next one.
Wednesday's tomorrow.
There's tomorrow, sir. So here we have a reaction. You have permanganate plus the oxalate ion yielding manganese plus carbon dioxide. What type of reaction is this? Or what type of equation is this?
Metal oxide plus hydrocarbon.
This is double replacement.
This was organic. Yields.
Is that a molecular equation? No, it is not. What type of equation is that?
Ionic.
It's an ionic. Very good. Looks like to me it's probably a net ionic at this point, yes? Very good.
Oh.
So the first thing we have to do is we have to figure out our half reactions. What are our half reactions? Well, how are we going to figure that out? Find the oxidation states. Thanks, Ben. I wish you didn't sound like someone killed your dog. All right. So what's the charge on your oxygen here? That's easy. That's -2. What's the charge on your manganese here? +7. What's the charge on your oxygen here?
-2.
-2. What's the charge on your carbon?
+3.5.
+3. Why did you say +3.5? It's always a whole number.
I was thinking about 7.
Okay. What's the charge on your manganese? +2. How about your oxygens? -2. So what's my carbon here? +4. So now we have to figure out our half reactions. So what is being oxidized and what is being reduced? Carbon is being oxidized. So carbon is going from what to what?
+3 to +4.
Okay, so we have C2O4, 2- aqueous, going to CO2 gas. That's one half reaction, correct? What's the other half reaction? The manganese, which is in the permanganate, so the MnO4-, which is turning into the Mn2+ aqueous. So we've separated them. Just for good measure, let's go ahead and label which is which. Which one's my oxidation?
No, the bottom. Wait, oxidation or oxidation?
Oxidation is the top one, and the bottom one is reduction. Very good. So that was our first step. We separated them into our half reactions. What's the next thing we have to do? We have to balance them. Which one do you want to start with?
Oxidation,
Do you? Okay.
because it's harder.
Actually, I don't think so, but okay. Yeah, definitely not in this case. No, that's okay. You said oxidation first. We're going to go in order then. So we have to balance it. So in order to balance it, I'm going to bring it down so I can write on it. C2O4, 2- aqueous, goes to CO2 gas. So what was our step? We have to balance it. We start with balancing our non-hydrogen and oxygen first. So that's just my carbons. How do I balance that? Put a 2 in front of this right here. Very good. Andrew. Okay. So that was A. Part B, we have to balance our oxygens by adding water if needed. But wait, my oxygen's already balanced, so I don't have to do that step. Yay! The next one is balance my hydrogens by adding protons if needed. Do we have any hydrogens? No. Already done. Fantastic. What's the final part we have to do here? We have to balance our charge, correct? By adding electrons. So what that means is you look at the total charge on one side of the equation and the total charge on the other side of the equation. So on this first side of the equation, what is my total charge? 2-. So -2. What is my total charge on this side? 0. So to which side will I be adding my electrons?
Hand side.
To the carbon dioxide gas. How many should I add? 2. So I'd say +2E-. And this half reaction is balanced. We followed the steps. We can't, now the next step says repeat for the next part. All right, so I'm going to bring it down. I have MnO4- aqueous going to Mn2+ aqueous. So what is our first step? Balance everything but hydrogen and oxygen, and it's already done. Sweet. Next step is balance my oxygens by adding water. So what do I have to do? I have 4 oxygens on my reactant side, so I need 4 oxygens on the product side. So I'm going to do +4 H2O over here. Your H2O, you know, is liquid. All right, so that did that. What was the next step? Balance the hydrogens by adding protons. So what do I need to do? Add 8 hydrogens or 8 protons to the other side. Fantastic. Now, what's the next step? Balance the charges. Remember, it's the sum of the charges. So here I have +8 - 1, which gives me +7. And on this side, I have +2 + 0, so I have +2. So what do I need to do? Add 5 electrons to which side? to the reactant side, plus 5 electrons. Very good. And when I do that, now my charges are balanced, correct? What's the next step? I'll do it to the other one. We already did that. Great. The next thing we have to do is what?
Add together.
Multiply by a number to make sure our electrons cancel out. So in this case, I have 5 electrons on one and 2 electrons on the other. What am I going to have to do?
Multiply 1 by 5 and 1 by 2.
So I'm going to multiply this one by 2, and I'm going to multiply this one by 5. And when I do that, my electrons should cancel out. So, oops, wait, come back here. You up here. There you go. You go right there. So I'm going to rewrite them. So I should have 10 electrons plus 16H plus aqueous plus 2MnO4 minus aqueous yields 2Mn2 plus 8H2O liquid. And then for my oxalate, I should have 5C2O4 2 minus aqueous going to 10 CO2 gas plus 10 electrons. So now what's our next step? Add them up, correct? Add your equations, just like you would in math class. So I'm going to have 10 electrons plus 16H plus 2MnO4 minus plus 5C2O4 2 minus yields, I'll make you a little smaller, yields 2Mn2 plus 8H2O liquid plus 10 CO2 gas plus 10 electrons. What's your next step? Cancel things out. What can cancel? Just the electrons at this point, right? So then what you do is you rewrite it and double check. Okay, 16H plus aqueous plus 2MnO4 minus aqueous plus 5C2O4 2 minus aqueous yields 2Mn2 plus aqueous plus 8H2O liquid plus 10 CO2 gas. So now we have to double check and make sure everything's balanced. So let's start with our hydrogens. I have 16 on one side. How many do you have on the other? I have 16 in my reactants. You have 16 hydrogens in your products, correct? And on the AH2Os? I have 2 manganese on my reactants. How many do I have in the products? 2. We're good. I have 8 plus 20. So I have 28 oxygens on my reactants. How many do I have in my products? I have 8 plus 20. I have 28. Perfect. I have 10 carbons. How many in my reactants? How many in my products? 10. So that's balanced. The other thing we have to check for is the overall charge to make sure the overall charge is balanced. So on this side, I have 16 positives minus 2 negative minus 10 negative. And it better be equal to, in this case, I have 4 positive. And that's it. So let's double check and count it up. Make sure. Is it balanced? So your final answer to the balanced equation would be all this. Okay?
Can we not do that?
I'm sorry, you have to. Was it hard to do?
No.
You just have to follow the steps. Do you want to try another one?
Try the word want.
In an acidic solution, let's say we have So what is that first ion? Perfect, dichromate, very good. So we have dichromate ion, an aqueous chlorine ion, and then it's going to chromium ion and chlorine gas. Again, what type of reaction do we have here? It's a net ionic, very good. What's the first step? Find the oxidation state so we can figure out our half reactions.
Wait, how did the oxygen just disappear? Oh, wait, never mind.
It's the net ionic. So what is the charge on your chromium here?
Plus 6.
Is there anyone who doesn't understand how they did that? Please tell me now.
So you write it out, so you equal negative 14 from the oxygen plus X.
You have 2x minus 14 equals negative 2, Charlie.
Yeah, okay.
Okay? It's just algebra. All right, how about my chlorine? What's the charge on it?
0.
Minus 1. I knew that because that's what's right up above it. I'm going to throw something at you.
No.
Okay. How about your chromium? What's the charge on it?
Plus 3.
Plus 3. And how about my chlorine gas?
Nada.
There we have 0. So now I have to figure out what's changing. So I'm going to have Cr2O7, 2 minus, aqueous, going into Cr3 plus, aqueous. Then I also have my Cl minus, aqueous, going to Cl2 gas. Which one is being oxidized and which one's being reduced?
Chlorine is the oxidized.
And you can use this from it.
So this is my ox and this is my red.
Red.
Or redox.
Look at that.
So if I were to look at it like this, what's the next step?
Balance the non-oxygen and non-hydrogen.
Well, no, we have to decide which one we're going to start with first, Ben.
Yes,
Just
it
pick
is.
one randomly.
But you still have to pick
You
one.
have to do them both eventually. We can
You
them
do,
both
I
at
just-
once if we wanted to.
Yeah, no, you probably shouldn't recommend that, Ben.
I could though if I put them in 2 different columns.
You could if you put them in 2 different columns. Absolutely. Bless you, bless you.
That's what I did with the last one.
All right, so we need to balance it. So what do I have to do?
Write it out.
I already did.
Multiply 2 on the
Put a
right
2 in
side.
front of the CR. Very good. So that's step A. What's B? Balance my oxygens. How do I balance oxygens?
Add 7 H2O to your right.
By adding waters. So I have 7 oxygens on one side. I have to add 7 waters on the other side.
You might have to add.
Now what's the next step?
How do you know there's some H2O?
Because I need 7. I have 7 oxygens here, Charlie.
Oh, okay.
I need 7 oxygens on the other side. The only way I can get an oxygen is by adding water.
Got it.
Okay? So now what do I have to do?
Add 14 hydrogen ions to the...
Add hydrogen, and I have 14 in my products, so that means, yes, I have to add 14 protons. All right, now what?
Balance the charges by adding electrons.
Balance the charges, so I have to count them up. So I have a positive 14, a negative 2 on this side, and then on this side I have 2 times plus 3 plus 0. So I have 12, and this side I have 6. So what am I going to have to do?
6 electrons on the reactant side.
So plus 6E minus. Everyone agree? So if I were to rewrite that one out, just so we have it, we had 6 electrons plus 14 H plus aqueous plus Cr2O7 2 minus aqueous yields 2 Cr3 plus aqueous plus 7 H2O liquid.
Why don't you write aqueous for the electrons?
They are aqueous for the electrons. I did write them as aqueous. Why do I? Because
Why
it,
don't you?
I did. Oh, you mean for the electrons? Oh, because the electrons aren't dissociated in solution.
What does it stick to?
They're attached to the other elements. they're coming from the other reaction. All right, so what's my next one? The Cl minus? So I have Cl minus aqueous going to Cl2 gas. Spoiler alert, balance. So I just put a 2 here.
You need more than.
That's balanced. Now what do I have to do? Balance my oxygens. There's no oxygen. Balance my hydrogens. There's no hydrogens. Balance my charges.
That's what you get.
So I have a negative 2 on this side and a 0 on this side. So what do you have to do, Hannah?
Add 2 electrons.
To which side? Well, the side I'm right. To this side. Very good.
Hannah's side.
So the next step would be what?
Add them up.
No, I can't add them up.
Oh.
You have to at least line
Yeah,
them up.
multiply.
Multiply to make sure my electrons are going to cancel. So I'm going to have to multiply this one by 3. So I should have, this one doesn't change. And then my next one is going to be 6Cl minus aqueous yields 3Cl2 gas plus 6 electrons. And now you have to add them up. When you add them, you end up with 6 electrons plus 14H plus. What's your next step?
Cancel and check
Cancel and check. So what can cancel?
the electrons.
Just the electrons. It's not always just the electrons, by the way, guys.
Do the electrons always cancel?
Electrons always must cancel out. That's the whole point of doing this. So then I'm going to rewrite it and double check. And we still have a net ionic. I have 14 hydrogens on one side and I have 14 on the other. That's good. I have 6 chlorines on one, 6 chlorines on the other. That's good. I have 2 chromiums, 2 chromiums. I have 7 oxygens and 7 oxygens. Looks like it's pretty good. What is your next thing that you have to do? Double check my charges. So on this side, I have positive 14, minus 6, minus 2. And on this side, I have positive 6. So 14 minus 6 is 8, minus 2 more is positive 6. So my charges are okay. So it is balanced. Does everybody see how to do that? One more, or are you good?
I'm annoyed.
Why are you annoyed? It gets more complicated.
It's tedious.
It's very tedious. I
That's why I'm
concur.
annoyed.
Well, sorry about your luck, sir.